Very good morning, class. See, in the previous videos, we have covered some fundamental laws of nature, and yesterday we have covered two more fundamental forces, that was electromagnetic forces and the nuclear forces. Now we are left with one more fundamental force, which is known as weak nuclear force. Yesterday we have done strong nuclear force, and now this is the weak nuclear force. So as the name implies, you can see that this force must act inside the nucleus, because as the name implies, nuclear forces, like in the strong nuclear forces, that force act between the proton-proton or neutron-neutron or proton-neutron inside the nucleus. Now similarly, the weak nuclear force, let's talk about it. So now we have weak nuclear force. Okay. If you remember, I have given you one equation when we were doing the conservation law of linear momentum. So in that law, I told you that when, in the case of beta emission, one neutron basically breaks into one proton plus one beta particle along with the anti-neutrino. Okay. Now I will not go into the deep. Just you can please have an idea that these electron, proton, neutron, they are in the different categories. They are in the leptons and the baryons. Just understand this: the electron and the proton, neutron, they are entirely different particles, right? Just understand this, because I'm not going into the deep, because this is not the part of your syllabus. This is a much higher studies of particle physics, so I'm not going in that direction. Just understand this: the electrons are some different kind of particles, and the proton and neutrons, they are some different kind of particles. Okay. Now in this case, you can see that the neutron is creating a proton as well as a beta particle. Beta particle is nothing but it is simply an electron. It is simply an electron. That means neutron are interacting with proton. That is no problem. Proton and neutron, they are in the same category. That is no problem. But neutron is also interacting with the beta particles, which is entirely different in different particles. So how they are interacting? How this neutron converted into the proton, into the electron? One type of particles converted into the another type of particle. So when these particles interact with each other, right? These heavier particle interact with the lighter particle. You can see here one more particle here. This is known as anti-neutrino. Anti-neutrino. This is also a very light particle whose mass is approximately negligible, right? And you know that the mass of again the electron is also very less. It is 9.1 into 10 to the power minus 31 kg. It is very, very less, minus 31 kg. And the mass of neutron and proton, it is approximately equals to 1.6 into 10 to the power minus 27 kg. So you can see that the mass of proton is 10,000 times heavier than the mass of electron. So due to the weak nuclear forces, they are able to interact with each other, right? So due to what I'm saying, that due to weak nuclear forces, these heavy particles can interact with the lighter particle. So this is your weak nuclear force. So Obviously, what are the range? Range, they obviously act inside the nucleus. So range is very short. Again, it is range is 10 to the power minus 15 meter to 10 to the power minus 14 meter, right? So we have completed all 4 fundamental forces that we have found in nature. If we name them according to their magnitude, that means how from the weakest force to the strongest force. So how we can arrange them? Let's see here. So the weakest force in nature is gravitational force. This is the weakest force. Let's say if the magnitude of gravitational force is taken to be 1, then the second powerful force is weak nuclear force. Although the name is weak, but it is stronger than the gravitational force. So if the magnitude of gravitation is taken as 1, then the weak nuclear force will be 10 to the power 26 times stronger than the gravitational force. Then we have the next force, that is electromagnetic force. Electromagnetic force. It is the second most powerful force in nature, and if you compare the magnitude of force with respect to the gravitation, then this will be 10 to the power 36 times. Is 10 to, that means take 10 and then add 36 0 after that, right? It is much more powerful than the gravitation. You can see, you can understand this by one example. You must have done a small activity, that take some pieces of paper and take a scale, and when you rub that scale on your head, on your hair, and that scale can attract the pieces of paper. Why? Because some charge is accumulated on that ruler, which attract the pieces of paper towards it. That means an electromagnetic force act between the ruler and the pieces of paper. Now just imagine the whole earth is attracting those pieces of paper toward it, but it can't overcome the force of attraction of that small scale. So just understand that in the magnitude of force, the force created by a small scale is much more than this big earth. So now you can understand that how much this electromagnetic force is powerful than the gravitation force. And the last, which is most powerful force in nature, is strong nuclear force. It is 10 to the power 39 times than the gravitation force. Okay, so these are from the weakest to the strongest force in nature. See, all these forces, each and every force have equal importance in the universe. We can't say that the gravitation is more important than the weak nuclear or the electromagnetic, or we can say that electromagnetic is more important than this gravitation, or we can say that we have the most strongest force, that is nuclear force, so we don't need these other forces. It is not like that, because all these forces have equal importance in the nature. If any one of these forces diminish, then we can't live in this universe. The whole universe will be torn apart, right? I'll give a small example. Suppose if the gravitation force stop working, then what will happen? As this gravitation force stop working, our sun will detach from our that Milky Way, right? Because you know that the sun is attracted to the center of the Milky Way, and that is why sun is at its position, right? Now, if sun is disliquated from its position, then obviously what will happen to the solar system? Because the whole solar system is at their place due to the attractive force between the sun and these planets. So if sun flew away, then obviously that there will be no planet or these satellites, they will also flew away, right? So that means the entire universe will they will fall out, right? So that is why the G force is so important. Now, weak nuclear forces, as I said, they interact with the lighter particle to the heavier particle. In the sun, what is the energy of sun? What is the source of energy of sun? It is basically nuclear fusion. In nuclear fusion, the lighter atom combine to form a heavier atom. It combines from proton, from the hydrogen. The two hydrogen come and they fuse into it, fuse in each other, and they form helium atom, and enormous amount of heat produced from it. So when some lighter atom interact with each other and they form some heavier atom, then the force included is nothing but weak nuclear force. I just explained you. So if these forces are cease to exist, then obviously what will happen? We can't have the energy that is happening in the sun, and without that energy we can't survive. The electromagnetic forces. Electromagnetic forces, one example, although they act in many places, but the most important example is all the electrons are attracted toward the electron attracted toward the center, that toward the nucleus. So if all these electrons, if this force breaks, if this force is to exist, then what will happen? All the electron will flew away from the atom. That means the stability of atom will be vanished. There will be no stable atom. There will be only nucleus, right? And if it happened, then it will flew like if you see the new movie that Avenger Endgame, what will happen when the Thor snap their finger? सारे के सारे ऐसे बिखर जाते हैं. Same thing happened with us, that the stability of atom will be vanished. All the electron will flew away from the nucleus because there is no electromagnetic attraction between the nucleus and the that electron. Now the last strong nuclear force, and I think you can figure it out, that if there is no strong nuclear force, then the stability of nucleus will be vanished, because nucleus is stable due to the strong nuclear force. The proton, neutron, or neutron are bound together due to this force. So if this force is to exist, what will happen? Then the nucleus will fall apart, right? So now you can see that each and every force is very, very important in nature. If we can say, if we don't have any single of this force, we can't survive. So these are the fundamental forces in nature. In this chapter, you have a list which shows some name of scientists, some Indian scientists and some foreign scientists, and their discoveries. So please go through it. See, although from this chapter hardly some question come in your examination, but see, this is not only about the marks. Education is about the knowledge, right? And if you ask your seniors and that what are the fundamental forces, how they act, so they might not answer it because they think that the first chapter, even this is not this chapter, they will not study it because they think that इसमें से कुछ आना ही नहीं है, क्यों पढ़ना है इसको. But see, again, I'm talking about, this is not about the marks. It is about the knowledge of these things, because when you study physics, you must have the knowledge of even the smallest thing found in nature, right? Obviously, if you don't know the ABCD, how can you able to form the sentences, right? So you must know all the basic, and that is why I took at least 3 to 4 days to complete this chapter. Okay, so please understand the importance of this chapter. Next chapter we have the unit and dimension. This chapter you have already done in the class 9th. The unit part is not so different. It is quite same as you've studied in the class 9th, like what are the types of systems, what are the fundamental quantities, and so on. So the unit part is absolutely same, but you have a new part in this, that is the dimension analysis. So dimension you have not studied in the class 9, so this will be the new part you will study, right? So let's quickly jump to the chapter unit. Okay, so we are not talking about the chapter units and dimensions. Quickly talk about the units. Units, why we need units. So before unit we understand measurement, why we need measurement. See, physics is the study of nature, right? So any study required some collection of data. Like suppose let's say I'm studying the gravity force. So to understand the force of gravity, I must collect some data of the gravity. I will take the ball, take it to the height and throw it. From that height, I will know the time taken by the ball from coming to the height to the let's say ground, what is the velocity. So all these observation we need measurement, right? And to measure quantity we need units, right? Because suppose I want, for some experiment I want some chemical. So how much chemical? There must be some unit. I just can't go to the shop and I'll say that I want the HCl, the hydrochloric compound. Then he must say that how much you want it. So I must say that I want 1 milliliter or 1 liter or 1 gallon, whatever. So we need units as well, right? To measure something. What is unit? See, unit is basically when we measure something, what we do? We compare one quantity with some another standard quantity, right? That is the measurement. Suppose you are going to the shop and you are saying that I want 1 kg sugar. What will shopkeeper do? He'll take some sugar, put in the polythene, and it will compare it from the 1 kg weight. So basically we are comparing, which is automatically we have some standard quantity. So this is your measurement. Unit is basically some standard quantities which is already derived, like we have we can say time, second and all, to show the measurements, right? These are the units. We have three systems of units. What are the three systems? First we have the MKS unit. MKS system is also known as metric system. So we usually in India we use the metric system, that is MKS. What is MKS? In MKS, the M stands for meter, K stands for kilo, and S stands for second. It means the three main quantity, which is length, mass and time, are given in the term of meter, kilo and second. Second we have CGS. In CGS, the length is in centimeter, the mass in gram, and time in second. And the last we have FPS. We usually don't use this system of unit. This system use in some foreign and in some European countries, but in India we do not use it. So in this case, the length is calculated in foot, the mass in pound, and the time is in second. So you can see that time is common in every unit. After that we have one more system, that is not SI, System International Unit. So these days usually we follow this system International Unit, SI unit, right? So these are the system of units. So in the next video, I will more talk about the units, what are the fundamental units, and what are the some units of, what the definition of time, second, length and all. I will cover in the next video. Thank you so much.